Okay, we're going to try to make this video quick because I know these have already been some long videos. So let's just jump into it. This is number 12, okay? This theorem here that we're going to prove is called the Base Angles Theorem, and it's on page 608 in your book. So let's grab that, take a look at it real quick, see what we're trying to prove, and then let's prove it. This is in 12.4, okay? And this is what we got going on here. Okay, the Base Angles Theorem says, if two sides of a triangle are congruent, then the angles opposite them are congruent. Okay, so in this case, you have this side congruent to this side, and they're marked with the little tick marks. Okay, that means that this angle has to be congruent to this angle. So the angle opposite is like directly across. If you draw a bisector through an angle, it hits the opposite side. Okay. So opposite means like across from. Okay, so if these two sides are congruent, these two angles are congruent. Let's think about this for a minute. What kind of triangle has two sides that are congruent? It's called isosceles, right? So this guy right here is true. When you see an isosceles triangle, sometimes this is called the isosceles triangle theorem. In an isosceles triangle, the two like bottom guys are going to be congruent. Now you can move this figure around, and so when we say bottom, what we mean is, or base, is basically, again, the ones that are opposite of the congruent sides. Okay, so this is a good image as well. Base angles here. Now you can have your triangle sideways, which we're going to see in a minute. Even though these aren't on the bottom now, they're still called the base angles. Because they're the angles that are opposite of the two congruent sides. Okay, so that's what we're going to prove. Now there's actually a proof for this in your book on 608, so if you want to use that as a reference, you can. I'm going to walk you through it because I think that'll be helpful. So in this proof here, notice again that this triangle's on its side, right? So what we're trying to prove is that this angle is congruent to this angle. Okay, that's our goal. Now, this kind of looks more like base angles, right? We have an isosceles triangle, and these are on the bottom. But really, the orientation or the way it's facing doesn't matter. What we want to say is when we have an isosceles triangle, the angles across from the congruent sides are congruent to each other. Okay, so we're going to prove it. We don't know that yet. We're going to assume that's true, but we're going to try to prove it. So the two sides of a triangle are congruent. Again, you have an isosceles triangle. Okay, then the opposite angles the angles opposite them are congruent. So we know AB is congruent to AC. What we want to do is prove that this angle is congruent to this angle. So right now, when we're talking about triangle ABC, that's our isosceles triangle. Okay, so right now, completely ignore that blue line in there. We're just talking about a triangle, an isosceles triangle. In this isosceles triangle, these two angles have to be congruent. This right here is what we call an auxiliary line. Auxiliary line. It's an extra line that we use for the proof. Okay, so it wouldn't necessarily be part of the original figure, but we would draw it in. That's why it's in blue. Okay, so let's start with our given and let's get started on this guy. So AB is congruent to AC. Given. Okay, and we want to say again that angle B is congruent to angle C. Okay, so the first thing we do is we draw an angle bisector. Now we can do that because we can construct a shape, and every angle has, one angle bisector. Of course, that's just kind of the nature of angles. So we're going to construct the bisector of angle BAC. Okay, and this is the justification here is, you can say construction or by construction. Okay, so we're allowed to make stuff like parallel lines to help us out. We're allowed to extend lines if we need to. We're allowed to like make or create a perpendicular bisector. Every angle has to have a bisector. It has to have a line that cuts it in half. So that's all we're doing, is we're just going to say, okay, cool, let's just assume that there's a bisector there. Okay, what this gives us now is it divides this into two congruent triangles. So now this original full triangle, ignoring the blue line, has been cut by the blue line into two triangles. And what we're going to do is we're going to show that these two triangles are congruent. And we're going to do it by side angle side. Okay. So what we're going to say now is that angle CAD is congruent to angle BAD. CAD is congruent to BAD. How do we know that? Again, bisector. The definition of bisector. Bisector means cut into two equal halves. Definition of angle bisector. Okay, cool. Let me erase this. We don't know angle C is congruent to angle B yet. That's what we're trying to prove. That's why I marked them there. But we can't use that in our proof because that's where we're trying to go. Okay, so the next step is to, well, we got side, right? Here's side. Here's angle. If we have another S, then we got side angle side, as long as it's the included angle. So side angle, we need this side. So what we're going to say is that segment AD is congruent to itself, segment AD, because this triangle shares this side AD with this top triangle, right? What's the justification there? Reflexive prop of congruence. Every segment is congruent to itself, okay? All right, so we got SAS. Cool. Now what we can say is these triangles are congruent to each other. Remember that when we do a congruent statement, the order of the letters has to match the order of the second part of the statement. So if we go CAD, the triangle, not just the angle, but triangle CAD, what corresponds to C? Well, it has to be B. So B has to start. C and B have to both be in the first position because those are the corresponding pieces. A corresponds to itself, D corresponds to itself. So CAD, the triangle, this lower triangle, is congruent to BAD, this upper white triangle. How do we know that? SAS. Side angle side congruence theorem, or congruence postulate, depending on, which book you're talking about. Okay, how does that help us? We just proved the two triangles are equal, or congruent. We wanted to prove two angles were equal. Okay? What do we know about congruent triangles? Once we know two triangles are congruent, we know that every piece has a corresponding congruent side. So if you remember, let's see if I can find it. This guy, this piece of information we looked at in the very first video. The corresponding parts of congruent triangles are congruent. CPCTC. So if these two triangles are congruent, I get all the pieces, right? I know that this piece, CD, has to be congruent to BD, because corresponding parts of congruent triangles are congruent. And I know that AD is congruent to itself. I already knew that this angle was congruent to this angle, because I started with that. I also now know that angle C is congruent to angle B. Why? Because they're corresponding angles. So once I have the two triangles are congruent, I get all the other pieces for free. Everything else is now congruent to its corresponding piece. So we're going to say that angle B is congruent to angle C. And the justification to that is that the corresponding parts, right, B corresponds to C, of these two congruent triangles have to be congruent. If these two triangles are congruent, these two angles have to be congruent. To just kind of abbreviate, corresponding parts of congruent triangles are congruent. CPCTC. Okay? So if you want to show that two parts of two triangles are congruent, you can show that the triangles are congruent first, and then go from there. Okay, let's use it now. We proved it, let's use it. Okay, in these problems, we're going to use the Base Angles Theorem to find the value of x. We also might use triangle sum theorem. Oh, we probably will. Okay, so check it out. Isosceles triangle, right? Here's the base angles. The angles up opposite the congruent sides. So if this one's 35, this one's got to be 35, right? So how do we find this one? Well, they all have to add up to 180, right? So 35 plus x equals 180. So 70 degrees plus x equals 180. right? Minus 70 minus 70. X has to equal, oh boy, 110. All right. Make sense? Yes. You said yes. I heard it. Okay, what's going on here? Pretty similar idea. All right, here are the two congruent sides. So the ones opposite have to be congruent, which means this is 53 degrees. Now you have to find this one. Okay. All right, let's look at some with some a little bit more algebra involved. Okay. Same two theorems we're going to use, right? Base Angles Theorem. These are the congruent sides, so this one has to be 70. Okay. So if this is 70 and this is 70, they all have to add up to 180, right? So measure of angle 2 plus 70 plus 70 is 180, right? That means the measure of angle 2 has to equal 40 if you subtract from both sides, right? So this has to be 40. Okay, is that what we wanted? Nope. We wanted to find the value of x. So we know this is 40, but we also know that it's 6x minus 8. So you got to solve this equation for x. Okay? Let's set up one more for you. Let's look at 18. Okay, this is 50 degrees, right? This is angle 2. What do we know about this? It's got to equal angle 2. Okay, so here's the deal. These three angles, let's call this 3. These three angles have to add up to 180, right? So I have angle 2 plus angle 3 plus 50 equals 180. If I subtract the 50 out from both sides, that means the measure of angle 2 plus the measure of angle 3 have to add up to 130 degrees, right? Because 180 minus that 50 is 130. So these two guys together have to add up to 130, right? But we also know that they're the same angle. So I can just say, well, what's 130 divided by 2? That's 65, right? So we know that they're the same. We know that they have to add up to 130. The only possibility is that they're 65 degrees. Okay, so 65 plus 65 is 130. 130 plus 50 is 180. Cool, cool, cool. Is that what we're looking for? Nope, we wanted to find the value of x. So we know the measure of angle 2 is 65 degrees. So 65 equals 8x plus 1. Solve this guy for x, and then you're good to go. So you're going to use this base angles theorem along with the triangle sum theorem. Fill in what you know about the angles, figure out what the missing angles have to be, and then you're going to set whatever equation you have equal to that angle to solve for x. So the first two are easy. X is the angle you're looking for. The last four, you find the angle first, and then set it equal to the expression, and then you can solve for x. Okay, that should help you get going. I know that's a little bit long, but hopefully that will help you get through most of it. You have 2 days to do this, so do maybe half an hour, one day and half an hour another day. But yeah, that should help you get through there, and that's the SAS congruence theorem and base angles theorem for you.